All right, so it's time now to start getting back into the code and start making use of this ERC20 contract that OpenZeppelin provides us. So what I'm simply going to do is I'm simply going to copy this code from here. So let me close this. So I'm simply going to hit copy from here, and I will go back to my Remix IDE. And in my Remix IDE, I'm going to open another ERC20.sol file. So I will click on create new file. And let me call this OpenZeppelin ERC 20.sol. All right. So let's call this OpenZeppelin, just so I remember, ERC20.sol. And over here, I'm going to paste the code for the ERC20 smart contract. How cool is that? And notice when I actually did that, you would have, if you had your eyes over here, you would have seen that a lot of folders and files got imported. And this remix basically does this automatically for us, because we have written an import statement which essentially says that import from this location within contracts and token and within ERC20 this file ERC20.sol. And we just had a quick look at this file and notice that this file also does another few imports. So this file is importing an interface. We don't have to get into these for now, but just for your understanding, this imports another Solidity file, a context.sol file, and some file called draft IERC6093. So this file, which is ERC20.sol, essentially imports another 4 Solidity files. And that's exactly what our Remix IDE has done. So it's essentially imported all the dependencies that are needed for this import statement to run. Now, what we have essentially done is that we have simply just copied this code from the copy function over here, and we have pasted this in our Remix IDE. So I'm going to close all these, and I'm going to focus over here. So this is the code that I have copied. Now, we discussed in great detail about the import statement. Now let's focus over here inside the constructor function. So this is where my contract starts. The name of my contract is GLD token, short for gold token. And it has a constructor which essentially takes 2 arguments. One is the name of the token and the other is the shortcode for the token. So let me use the previous names that I used, which was block. So the token that we created had the name of block in our intermediate series, and let me give it the short code of BLK. So I've essentially used the same name of the token block and given it the same short code. Now, msg.sender is the person deploying this smart contract, and the initial supply, recall that we had total supply when we were doing the basic course, and in that total supply we had given some value. So this is the initial supply that we will give. Now, let's first just deploy this in our local virtual blockchain using Remix IDE, and let's see this one in action. So I'm simply going to go to my compiler. I'm going to compile my smart contract, and I'm going to then deploy it. So to deploy it, I'm simply going to give it some initial supply, which is what it is asking over here. So I am going to take a very high initial supply this time. So I'm going to add a couple of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's a very high total supply that I've given, but let's see what happens. So yeah, I have used injected MetaMask, and I'm just going to change this to back to my local VM. So I'm not deploying this on Sepolia at the moment, and it's picked up some default addresses. So I'll let the first one be as is, and then I'll hit deploy. Now, here is my ERC20 contract that I've copied from OpenZeppelin, and it is successfully deployed on my local VM blockchain. Now I can interact with this smart contract exactly how I would interact with my custom built ERC20 smart contract. So notice that it has all the functions: approve, transfer, transfer from. It has the allowance function. It has the balance of function, decimals, name. So if I click on name, it returns me the name. It has the symbol function, returns me the symbol for my ERC20 token. If I click on total supply, it also shows me the total supply of the tokens that I set when I was setting up the smart contract. So it has all the functions that my ERC20 token contract should have, and that's all what I have done. I simply went to OpenZeppelin. I copied this piece of code from here. I pasted it in the Remix IDE. I've got all the functions that the ERC20 contract should have. And this is a battle-tested, audited, pretty much free of security vulnerabilities, ready to production use smart contract from OpenZeppelin. And I can essentially use this and generate ERC20 tokens and put them into production use. How cool is that? So I hope this gives you a good understanding of how you can use ERC20 contracts from OpenZeppelin and quickly deploy them into production. We've deployed it in a local VM environment, but you know the steps of deploying it on Sepolia as well. So I hope that was a good explanation of the process. And with all of that and more in the next video.